Hi everyone, I welcome all of you in this session. Dear children, we have discussed in earlier lecture that basic proportionality theorem and converse of the basic proportionality theorem. Now in this lecture, we will be continuing with the same, and we take some few more examples based on basic proportionality theorem and converse of the basic proportionality theorem, and further we will discuss some criteria for similarity of two triangles. So first of all, let us take an example based on this basic proportionality theorem and converse of basic proportionality theorem. So the example is here: using basic proportionality theorem, prove that a line drawn through the midpoint of one side of a triangle parallel to the third side then bisects the other side as well. So let us draw first of all a triangle ABC. According to the statement of the question, a line is drawn through the midpoint of one side of a triangle. Let us take the midpoint here of side AB. Let this midpoint be D here. The question is a line drawn through the midpoint of this, that is from point D. This is DE, and it is given that this DE is parallel to the side BC of a triangle ABC. Then we have to show that this E is the midpoint of the line segment AC here. So let us take given here in this question. Given a triangle ABC D is the midpoint, or we can write it as AD is equal to DB, and DE is parallel to BC. This is the given information in the question. So D is the midpoint, that is why we can write here AD is equal to DB and DE is parallel to BC. Then to prove, we have to prove here that E is the midpoint of AC. E is the midpoint of AC, that is AE is equivalent to EC. Then proof. Recall the basic proportionality theorem. We have learned in basic proportionality theorem that if we have a triangle and one line is parallel to one side of a triangle, and then it divides the two sides of a triangle in the same ratio. Look at the figure here. ABC is a triangle, and it is given in the question this DE is parallel to BC side of a triangle ABC. So in proof we have to take this triangle. In triangle ABC, this DE is parallel to side BC. Therefore, this line DE divides the two sides in the same ratio. That means we can write it here: AD divided by DB is equal to AE upon EC. The reason is here by basic proportionality theorem. By basic proportionality theorem. So AD is equal to DB and AE is equal to EC. But in given we have here AD is equal to DB because it is given in the question D is the midpoint of AB. So we can write it as AD by DB. But the value of DB is equal to AD here. We can write DB as AD is equivalent to here AE upon EC. So now we can write here AD is the numerator and same is the denominator AD. We can cancel out the two. Here we can write here it is 1 is equivalent to AE upon EC. So when we multiple, you get EC into 1 is EC is equivalent to AE. Now look at the to prove condition here. We have to show that this E is the midpoint of the line segment AC, and we have proved it that EC is equal to AE. Means if EC is equal to AE, what does it mean? It means this point E is the midpoint of AC. Therefore, E is the midpoint of AC. Therefore, E is the midpoint of line segment AC. So when we have a triangle, and if we have it is one of its midpoint, and this D is the midpoint here, D is parallel to the side BC, and we have to prove that it bisects the third side AC as well. So we take a triangle ABC using basic proportionality theorem. We get AD divided by DB is equal to AE upon EC, but the given condition is D is the midpoint. It means AD is equal to DB. So we use here, we replace this DB by AD, because in given condition it is AD equals to DB and AE equals to EC. So we cancel out AD and AD, it becomes here 1. We multiply here, 1 into EC is equal to AC, EC is equal to AE. So it means when EC is equal to AE, it means this E is the midpoint of the line segment AC. So let us take another example, that is ABCD is a trapezium in which AB is parallel to CD and diagonals intersect each other at O. Then show that AO by BO is equal to CO by DO. First of all, let us draw the diagram of the question. ABCD is a trapezium the trapezium is A, B, C and D. We know that if ABCD is a trapezium, then it is one opposite pair is parallel. It is given in the question that AB is parallel to CD, and further the diagonals intersect each other at point O. So let us draw its diagonal here. Diagonal AC and a diagonal BD. They intersect each other at point O. Let this point be O here. This is the information in the question given, and what we have to prove, we have to show that AO by BO is equal to CO upon DO. First of all, right, the given condition is here. So given, what is given here? ABCD is a trapezium. ABCD is a trapezium in which AB is parallel to CD, and then to prove, we have to prove here that is AO by BO, this is to prove AO upon BO is equals to CO by DO by DO. Now, once again recall the basic proportionality theorem. In basic proportionality theorem, we have learned that if we have a triangle and we have one line parallel to one of its side, then we use basic proportionality theorem. Here we have so many triangles here, but no one line is parallel to any other side of the triangle. But here we have AB is parallel to DC. So for this we have a construction here. This is construction. Draw EO parallel to AB, and further AB is parallel to CD. It is given. So we draw here EO, which is parallel to CD, and CD is also parallel to AB. This one. This is point E here. By construction, this EO is parallel to DC, and this EO is same parallel to AB. Why? If EO is parallel to DC and DC is also parallel to the line segment AB to the side AB here, so all of the three line segments are parallel to one another. That is, AB is parallel to EO and EO is parallel to DC. Now let us take a triangle. Now let us take proof of this question. It is here. Now take a triangle ADC. Why we take this triangle ADC? Because in this triangle we have a side DC, and by construction this DC is parallel to EO. Then this parallel line divides the two sides, that is AD and AC of a triangle ADC in the two ratios, that is AE by ED. We can write it equals to AO by CO. So now take triangle in triangle ADC. What is given here? It is EO parallel to DC. It is by construction. So when we have ADC triangle and EO is parallel to one of its side, then we use basic proportionality theorem, and we can write this AE divided by AE by DE is equivalent to this AO upon CO. It is AO by CO. The reason is, and we call this as 1, the reason is by basic proportionality theorem. It is by basic proportionality theorem. So now let us take another triangle. Observe the figure keenly. So if we take a triangle ABD, A, B and D, which line is parallel to one of its side? Exactly, EO is parallel to AB side. And when we have a triangle and we have one line parallel to one of its side, then we use basic proportionality theorem. Now which triangle we are now taking to this? A, B and D. In triangle again, A, B, D. In triangle ABD, we have here same EO is parallel to AB side here. Then we use basic proportionality theorem. So we can write here simply AE by ED. We have taken triangle AB and this, we can write AE by ED. Their ratios, that is AE upon ED, is equal to BO by DO. It is BO upon DO, and we call this as second equation. Reason is same, by using basic proportionality theorem. Now if we look at the two equations here, equation 1 and equation 2, what we observe here, the left hand side is of both the two equations, that is AE by DE here in equation 1 LHS, and in equation second we have same AE by DE, or we can write it as AE by ED. So when left hand sides of the two equations are same, and if we compare the two equations, we know that things which are equal to the same thing, they are equals to one another. So we can write here from first and second, we can write from 1 and 2. We get, so on comparing the two, the left hand sides are equal, so we can write AO by CO, that is right hand side of the second equation, is equal to the right hand side of the second one. So right hand side of the second one is BO upon DO. But look at the to prove condition. What we have here written, we have to prove here AO by BO is equal to CO upon DO. But what we have proved? AO by CO. But what is it here? BO. So we have to replace this CO by BO and BO by CO. So that means we have to interchange these two here. If we write here AO by CO, not CO, but we interchange BO with the CO. So BO here we can write it as BO, and we interchange this CO to here in place of BO, CO upon DO. Yes, this line segment, or we can say that the diagonals of the trapezium are divides each other proportionally. That means the diagonal AO by BO, it is AO by BO is equivalent to CO upon DO. So let us take another concept, that is similarity of two triangles and criteria for similarity of two triangles. So in earlier lecture we have discussed that the similarity of two triangles, there are two conditions when two triangles are similar. First one is when the corresponding sides of two triangles are proportional, and if the corresponding angles of two triangles are equal, then the two triangles are said to be similar to each other. Now, there are various criteria to prove that the two triangles are similar or not. So let us take criteria for similarity of triangles. So let us take all of the three. First one is, that is side, side, side. Side, side, side criteria, or we can write it as SSS. Second one is side angle side. Side angle side, that is SAS. SAS rule. And here third one is angle, angle, angle. Angle, 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 that is angle, angle, angle criteria, or we can write it as angle, angle side. That is angle, angle here. So these are the three criteria for the similarity of two triangles. So let us take one by one. First one is side, side, side similarity. If in a triangle, if three sides of a one triangle are respectively proportional to the three sides of the other triangle, then the two triangles are said to be similar to each other. Let us take an example for this first criteria, that is side, side, side here. First one is side, side, side. Let us take an example here. Consider a triangle ABC. This is A, B, C, and a triangle PQR. This is triangle another PQR. If the sides of a triangle is here 2.5, it is 2.5 centimeter, and let it be here 3 centimeter, and this one be here 4 centimeter. This is 4 centimeter. And let us take the sides of the triangle PQR here. Let it be 5 centimeter. This is 6 centimeter, and this one be 8 centimeter. Now observe the three sides of a one triangle and three sides of the other triangle PQR. The side AB is here 2.5 centimeter. This is 2.5 centimeter, and the side PR is here 5 centimeter. AB side is proportional to here PR side, not AB is proportional to PQ, because AB is here 2.5. We stretch this triangle up to its double length. That means if AB is 2.5, we double the side PR, that equals to 5 centimeter. Similarly, BC is here 3 centimeter. The side QR is corresponding to it, that is 6 centimeter. The BC side, the double of BC is here QR, that equals to 6 centimeter. Similarly, AC corresponds to PQ side here. Now let us find the ratios of these sides. So in these two triangles, we can write AB by PR is equal to BC by QR is equal to the side AC here is equal to PQ side. Both of them are equals to here. We can write AB by PR is equal to BC by QR. So what will be the ratio of all the three here? It equals to 1/2. So the three sides of a one triangle, that is ABC, are respectively proportional to the three sides of the other triangle PRQ. Both are equals to 1/2. So the two triangles are said to be similar by the rule side, side, side similarity. So we can write here, therefore triangle ABC is similar to triangle PRQ. PR and Q. One thing you have to remember here, order of the triangle is most important here. You cannot write ABC is similar to triangle PRQ. Why? Because AB is corresponding to PR. AB is not corresponds to PQ side here. That is why we take triangle here ABC. This AB corresponds to PR. Simply this BC side is corresponds this BC side, this BC. That equals to 3 centimeter here, and this is equal to QR here, that equals to this one is equivalent to 6 centimeter here. So if we triangle ABC triangle, then we have to take here P, R and Q triangle. So these two triangles are similar by the criteria side, side, side similarity. Now let us take another one, that is second one, side, angle, side. So the statement of the second criteria, side, angle, side, is if one angle of a triangle is equal to one angle of the other triangle and the side including these two angles are proportional, then the two triangles are said to be similar to each other. So let us take an example for the second criteria, that is side, angle, side here. This is second criteria is side, angle, side. So let us take two triangles ABC. Let it be A, B, C, in which AB is equal to 6 centimeter and AC is equivalent to 4 centimeter. Now let us take another triangle. Let it be PQR here. This is P, Q and R, in which we have this is equivalent to 2 centimeter, this will be 3 centimeter. The unit is here centimeter. And in this triangle ABC, if angle A, this angle A is equal to angle Q, this angle. So look at the two sides of the triangle first of all. So here we have a side AB and we have a side QR. We have side here QR because AB is here 6 centimeter and QR is its half, that equals to 3 centimeter. Similarly the side AC is 4 centimeter and the side here PQ is its half, that equals to 2 centimeter. And the angle A is equal to angle Q here. First of all we can write the corresponding side is here. We can write here AB upon the side AB is a 6 centimeter and we can write it equals to QR is proportional to the side QR, and another side that is AC is equal to AC upon the side is here AC 4 centimeter and we can write it as QP or PQ. So by this it equals to QP, and when we find the ratio it is 6 upon 3 and 4 upon 2. What will be the ratio? It becomes 2 upon 1 is the ratio. And the angle A here, this is angle A, is equivalent to angle Q here. So by which criteria the two triangles are similar? Definitely they are similar by side, angle, side similarity. So therefore we can write here triangle ABC. Once again I am going to repeat this. The order of the triangle is very, very important here. If we take triangle A, B, C, so is similar to triangle. A corresponds to angle Q. It is not P, Q and R here. You cannot write ABC is similar to triangle PQR. No, we have take here angle A, this vertex A. This angle A is corresponding to angle Q. So we start with the triangle. It is Q. Then we side it is AB. So it is a 6 side here centimeter and it is corresponding is equal to QR. So we can write it is QRP. So these two triangles are similar. The order of the triangle is very, very important here. You cannot write ABC is similar to triangle PQR. It is incorrect one. So you have to take order accordingly, their corresponding sides and their corresponding angles. A is corresponding to Q. That is why we start QA here and Q here. AB is here. That equals 6 and QR is here 3 centimeter. Simply AC side is equal to 4 centimeter and QP side is equivalent to here 2 centimeter. So the two triangles are similar by the criteria, that is side angle side similarity rule. Now let us take another one, that is third one here, angle angle similarity. The statement for this third criteria, that is angle 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 similarity, is if three angles of one triangle are respectively equal to the three angles of the other triangle, then the two triangles are said to be similar to each other. So let us take another example for this third one. So if we have a triangle here ABC like this, another example A, B, C, and let us take another triangle here DEF, D, E and F, D and F. If the angle B is equivalent to 50 degree and this angle C is equivalent to 60 degree, is equal to 60 degree, and here in triangle DEF this angle E is same as 50 degree and angle F is 60 degrees. So we have two angles of these two triangles are same. By using angle sum property here, we can find the third angle of both the two triangles. So we know that angle A plus angle B plus angle C is equivalent to 180 degree by angle sum property. So here this is 60 and this is 50 and 60. 60 plus 50 is equal to 110 degree. So if we subtract 110 from 180, what will be the measure of angle A here? Yes, it equals to 70 degrees. It equals to 70 degree. Similarly here, third angle, angle D is equal to 70 degree. What we observe from the two figures? So three angles of a triangle ABC are respectively equal to the three angles of the triangle DF. So the two triangles are said to be similar to one another. Here, if we have only two angles of a one triangle are equal to the two angles of the other triangle, then we can say that the two triangles are similar to one another. So now let us take some examples based on these criteria to understand this concept clearly. So let us take few more examples based on these criteria, that is similarity criteria here. So this is a question number 8 from textbook exercise number 6.3. So question is a point on side AD produced of a parallelogram ABCD in which BE intersects CD at point F, then show that ABE triangle is similar to triangle CFB. So let us draw the figure of the question. So ABCD is a parallelogram. First of all, ABCD is a parallelogram. This is here A, B, C and D. According to the question, E is a point on side AD produced. So if we produce this side AD up to point E, and if we join B to E, this one, it intersects the side CD at point F, this point F here. So we have to show that triangle A, B, E is similar to triangle C, F and B. So the first of all given is given condition is here ABCD is a parallelogram, ABCD is a parallelogram. So we have to prove here triangle ABE. So to prove, triangle ABE, this triangle ABE is similar to triangle CF and B. CF and B. So first of all, observe the figure keenly. What we have to prove here? Triangle ABE is similar to triangle CFB. So we know that in a parallelogram, opposite sides of a parallelogram are equal and parallel. Here we have a side AD and a side BC. Definitely they are parallel to one another. Is there any line which is connecting both the line AD and BC? Yes, we have a line here BE. It intersects the AD produced at A and this BC at B. So we have two angles here. This angle 1, we name this angle as angle 1, and this is angle 2 here. Yes, what the two angles are said to be here? Yes, very good. It is a alternative interior angles. So when we have two parallel lines and is intersected by two transversal, then angle 1 and angle 2 are alternate interior angles. We know in earlier classes that alternate interior angles are always equal when the lines are parallel to one another. So this one is angle 1 equals to angle 2. Similarly, if we have considered another this parallelogram A, B, C and D, what can you say about the angle A, this angle A and angle C? Can we say that the two angles are equal? Definitely they are equal. Why they are equal? Because opposite angles of a parallelogram are equal to one another. So now we are going to prove this ABE is similar to triangle CF and B. So let us take proof of this question here. So in parallelogram ABCD, in parallelogram ABCD, in parallelogram ABCD, we have AD is parallel to BC side and BE is a transversal. BE is a transversal. Therefore, we can write here angle 1 is equal to angle 2. Angle 1 is equivalent to angle 2. What is the reason? Alternate interior angles. So we can write here alternate interior angles. Similarly, angle A is equal to angle B. What is the reason here? Why angle A is equal to angle C? Because both are opposite angles of a parallelogram. So also we can write here this angle A is equivalent to angle C. The reason is opposite angles of parallelogram. Opposite angles of parallelogram. Now let us take a triangle that is A, B and E and triangle C, F and B. Now in triangle ABE and triangle CF and B, CFB. We can write here angle 1 is equal to angle 2. Angle 1 is equivalent to angle 2. What is the reason? It is proved above here in this one. So it is proved. Again, angle A is equal to angle C. Same reason proved above. By which criteria the two triangles, that is triangle ABE is congruent to triangle CFB. So the criteria is, that is angle rule. The two triangles are said to be similar to one another. Therefore, we can write here triangle ABE is similar to triangle CFB. Triangle C, F and B, the reason is by angle similarity rule. So the two triangles are similar by using the criteria angle rule. So this is all for today. We'll meet you in the next session. Till then, take care of yourself.